Hey guys, so I just wanted to make a quick video about lesson 12, which covers transformations and piece functions. So I'm going to go through question number 14 that asks for the function f of x, find f of 1, f of negative 1, and f of 2, and then sketch the graph of the piecewise defined function that determined the domain and the range of the function. So the first thing we're going to do is evaluate f of 1, f of negative 1, and f of 2. So the way you do that is for f of 1, you have to evaluate for your if statements. So if x is less than or equal to 1, and if x is greater than 1. So in this case, x equals 1. So it's going to be in your first if statement where x is less than or equal to 1. So then it's just a matter of plugging 1 in to this guy. So it's just a matter of taking 1, plugging it in for x, and evaluating. So 4 times 1 is 1, 4 minus 2 is 2. So that's how we got 2 for that guy. Next, actually, that's supposed to be an arrow. Next, we have to evaluate f of negative 1. So again, you have to evaluate your if statements. If x is less than or equal to 1, or if x is greater than 1. Well, clearly, negative 1 is less than or equal to 1, right? So it's, again, a matter of plugging in that value into x. So we have 4 times negative 1 is negative 4. Negative 4 minus 2 is negative 6. And so that is how we got negative 6. So now finally we'll evaluate f of 2. So in this case x equals 2. So we're going to go back to our if statements where x is greater than 1, because 2 is obviously greater than 1. And then you plug in 2 for x. So 2 plus 4 equals 6. So that's how we got 6 for that answer. And then you have to graph it. So the graphs can be a little bit tricky, but what I suggest is taking, think about what your graph would actually look like. So a line y equals x, that's just a line through the origin. And so then you have to evaluate x greater than 1 and plus 4. So you're going to move up 4 units. And it's only going to be for x greater than 1, which means that's going to be an open circle there. And so in that case, that's going to be our line for that one. Let me erase this one. So that's before the transformation. So then you want to evaluate the next one. The next one is 4x minus 2 if x is less than or equal to 1. So this one has a stretch, I think, and it's minus 2 units. So you're going down 2 units for if x is less than or equal to 1. So that's going to be a filled in circle. Or actually, hold on, sorry. Oh, to the right. Wait, hold on, to the right. To the right 2 units if x is greater than 1. So, if x is less than or equal to 1. So that's where we're going to get our filled in circle there, and it's going to look something like that. And so that's our transformation for 4x minus 2, and that's how we got A as our answer. So then finally, it's asked to evaluate the domain and range. Well, the domain is all x values, so you basically read the domain from left to right. Well, you can see, as you read from left to right, no points stop, because at x equals 1, this filled-in circle accounts for the open circles, so that's how we get our domain as negative infinity to infinity. It's all real numbers. The range is a little bit different, however. So the range, you have to read from bottom to top, and you see, at this point, we have a little break, right? And so for the range, we have the graph goes down to negative infinity to a point where we don't know, obviously, and then it goes up to y equals 2. And so at y equals 2, we're going to put that in there, and it's because it's a filled in circle at that point, we're going to use a bracket. And then the union accounts for that little jump in between. And then we're going to start again at y equals 5. But at y equals 5, it's an open circle, so we need to use a parenthesis there. So 5, and then again, the graph goes off into positive infinity farther than we even really know, right? And so that's our range. So our range is a little bit trickier than the domain, but That's it for this one. If you have any questions, please feel free to reach out. Otherwise, thanks for watching.